we handle classroom workbook based on the questions on method 1, 2, 3 and 4. All of you just go through handouts. We discuss classroom workbook. Now before discussing questions, let us see what type of questions you may expect in GATE. Generally for all types of questions, one particular issue is finding general solution. So let me discuss what type of models you can expect in GATE or IES from differential equations, particularly from first order, first degree differential equations. Sometimes questions may be like this. A first order, first degree differential equation will be given. dy by dx equal to f of x comma y. So directly one model is they may ask you finding general solution. Finding general solution of this equation. Directly first order, first degree differential equation will be given. You need to find its general solution. Another one is finding particular solution. Finding particular solution. So particular solution is possible by giving one boundary condition. Just we call it as y of x naught equal to y naught. See, if they ask you directly finding general solution, then whatever the method is applicable, you apply that method, do the necessary integrations or derivatives as per requirements of question and get the solution. It's a simple task. But if they ask you particular solution, that means one equation will be given, the boundary condition will be given, they will ask you directly its particular solution is, options will be given. If the options are given, if it is related to particular solution, then you need not require entire calculation. One simple point is just verify options. Suppose I will give you one general example by taking one particular boundary condition. Suppose the boundary condition is y of 1 equal to 2. Suppose the options are like this. For example, x square plus 1. This is particular solution. Second one is x plus 1. Third one is, for example, 4x minus 2. And third one is, for example, this is x plus 9. See here, when y of 1 equal to 2 means what? When x equal to 1, the value of y is 2. All these are y values. There is some question. dy by dx equal to f of x comma y. Whose boundary condition is y of 1 equal to 2? So these are my particular solutions. In that case, you need not do entire calculation. Just go through verification of options. Replace x by 1, the y value is giving 2. So if an option satisfies given boundary condition, it may be right answer or may not be right answer. I will give explanation. So do not confirm, do not eliminate this. Hold it. Here also when you replace x by 1, the answer is giving 2. Do not confirm, do not eliminate. Here also when you replace x by 1, the answer is 2. Don't confirm, don't eliminate. But when you replace x by 1, the answer is 10, but y must be 2. So fourth option does not satisfy given boundary condition, so eliminate this. Therefore, in this question, just by using boundary condition, I have eliminated only single option. Sometimes 3 options can be eliminated. So in that case, fourth option is right answer. If option A fails to satisfy boundary condition, option C fails to get boundary condition, option D fails the boundary condition, so A is eliminated, B can be eliminated, D can be eliminated, then rest all will be correct right answer. But sometimes if you are unlucky, all options will satisfy boundary conditions. In that case, you need to do at least 50% calculation. So let me go through all this. This is another model. And third model is interesting model. This question they were asking from last 6 to 7 years, particularly from GATE 2012 onwards. Questions will be like this. They will ask you, they will give you one first order first degree differential equation, that is dy by dx equal to f of x comma y. They will give one boundary condition. You know the importance of this boundary condition. First find the general solution. If the general solution contains general constant c, to get this constant, you apply this boundary condition. Now, after that they may ask you this, what is y of x1? Questions will be like this. So first order first degree differential equation is given, boundary condition is given. Just by using first order first degree differential equation, you will get the general solution. Whatever the method is possible, you apply that method and do the necessary derivatives and integrations, you get the answer. That is called general solution. And then apply this boundary condition to get C value. After that, they may ask you what is y of x1. So in that case, even if options are given or if options are not given, you must do entire calculation. This is one important model. First model is just finding general solution. Second one is finding particular solution. Third one is after finding particular solution also, that is finding C, you need to replace x by x1. This is interesting model, right? But if only particular solutions are given, go through verification of options. If only one option satisfies the given boundary condition, that could be right answer. Even the same logic you can implement for higher order differential equations also, because when you are handling second order equations, if they expect particular solution from us, they used to supply two boundary conditions. So assume that options are given A, B, C, D. If at least any one of the boundary condition does not satisfied by option A, eliminate that. If both boundary conditions are satisfied by B, then do not confirm, do not eliminate, put it hold. If at least one of the boundary condition does not satisfy by option C, eliminate that. The same case is valid for D also. So if all boundary conditions are satisfied by any option, that may be right answer, may not be right answer. But if it fails to satisfy that boundary condition, then 100% it's a wrong answer. Let me give clarification. Suppose the condition is this, y of 1 equal to 2. So that means x value is 1, y value 2. That means the curve is passing through the point 1, 2. Assume that this is the point 1, 2. So multiple curves may pass through this. But if a curve does not pass through this, it's not a right answer. So here 4 to 5 curves are passing through this point P1, 2. That curve may be this or maybe this or maybe this. We do not guess. But if a curve does not pass through given point 1, 2, 100% it's not a particular solution, right? That is the logic. So hope you understand all this. Now basing all these ideas, let us proceed to classroom workbook based on method 1, 2, 3 and 4. Right? Just go through handout. Let us start with question number 1. Let us go through question number 1. What it is? The solution function y equal to f of x of an ODE dy by dx equal to 3x square minus 2x passes through the point 1, 1. The magnitude of y at x equal to 3. So they were asking this, y of 3 equal to what? So the solution function y equal to f of x of this equation passes through this. Then what is y of 3? That means you need to solve for general solution. So solve this equation to get general solution. Apply this boundary condition, you get general constant C. And in that solution, in that particular solution, replace x by 3. Right? Now let us try to solve this equation. So when you want to handle these questions, you must do entire calculation. Let us start with solving this equation. What is my equation? Dy by dx equal to 3x square minus 2x. Now cross multiply this equation, dy equal to 3x square minus 2x dx. Now variables are separated. Apply integration on both sides. So integral dy equal to integral 3x square minus 2x dx plus c. So this implies integral dy equal to y equal to x cube minus x square plus c. Now this is my general solution. Y equal to x cube minus x square plus c. Now this is my general solution. Apply this boundary condition. It passes through 1, 1 means when x equal to 1, the value of y is 1. Therefore replace x by y by 1. In this case 1 equal to 1 cube minus 1 square plus c. This implies c value equal to 1. Now substitute c value in the general solution. My particular solution becomes y equal to x cube minus x square plus 1. It is my particular solution. but they were asking magnitude of y at x equal to 3. So replace x by 3, 3 cube minus 3 square plus 1. This is 28 minus 9, this is 19. So the answer for this question is 19, that is option number C. So option C is right answer for this question. Please note this. For a differential equation, y cube into dy by dx plus x cube equal to 0 and y of 0 equal to 1. What is y of minus 1? It's a blank question. It is a first order, first degree differential equation. Solve it, you get the general solution. Apply boundary condition, you get C value. And in the final particular solution, replace x by minus 1. This is same as previous question, but the differential equation is somehow different. Let us handle this. This is y cube into dy equal to minus x cube into dx. Variables are separated. Apply variable separate method, that is integral y cube dy equal to minus integral x cube dx plus c. So this implies integral y cube is y power 4 by 4. This is a minus x power 4 by 4 plus c. So this implies x power 4 by 4 plus y power 4 by 4 equal to c. This is my general solution. Now in this general solution, apply the boundary condition y of 0 equal to 1. That means what? When x is 0, y value is 1. Substitute these values in this general solution. We get x value 0, y value 1. So therefore 1 by 4 equal to c. So c equal to 1 by 4. Now substitute c value 1 by 4 here. So the particular solution is x power 4 by 4 plus y power 4 by 4 equal to 1 by 4. This implies x power 4 plus y power 4 equal to 1. This implies y power 4 equal to 1 minus x power 4. This implies y equal to 1 minus x power 4 whole power 1 by 4. Now this is my particular solution. But what we require is y of minus 1. Replace x by minus 1. So y of minus 1. When you replace x by minus 1, the result will be 0. So the final answer is, it is 0. Note this. Now let us discuss question number 3. What it is, if y of x is a solution of the equation y into y dash equal to 8x, comma y of 0 equal to 2, comma the absolute value of y of 2 is. Again, this is a kind of previous two models, two questions. Let us handle this. What is my equation? Y into y dash equal to 8x. The boundary condition is y of 0 equal to 2. They were asking absolute value. Absolute value means modulus. So what modulus makes? If it is negative value, modulus makes it positive value. So we need to find out this. It's a blank question. Now let us handle this by using again separation of variables. Y dash means dy by dx. So this is y into dy by dx equal to 8x. This implies y dy equal to 8x dx. So variables are separated. Apply integration on both sides. Integral y dy equal to integral 8x dx plus c. Integral y dy is y square by 2. Integral 8x is 4x square plus c. Now this is my general solution. Apply this boundary condition. What does it mean? X value is 0, y value is 2. So y value is 2. Therefore y square is 4, 4 by 2, 2. X value is 0. So the value of c is 2. Substitute c value 2 here. We get y square by 2 equal to 4x square plus this is 2. This implies y square equal to 8x square plus 4. So this implies y equal to plus or minus, it is 2. So plus or minus square root of 8x square plus 4. Since they were expecting modulus value, it is positive value only. Therefore, I can take y equal to square root of 8x square plus 4. So y of 2, replace x by 2, 2 square 4, 4 8 32, square root of 36. So the answer is 6. Therefore, final value is, that is y of 2, that is. Now we move to question number 4. What it is? Consider an equation dy by dt equal to minus 5y with initial condition y equal to 2 at t equal to 0. Then the value of y at t equal to 3. We need to find value of y at t equal to 3. Of course, options are given. Even if options are given, for the models of like this, you won't get any benefit. So we need to solve completely this question. Let us see this. Dy by dt is minus 5y. So therefore dy by y equal to minus 5 dt. Variables are separated. Apply integration on both sides. Integral 1 by y dy equal to minus 5 into integral dt plus general constant c. This implies this is log y equal to minus 5t plus c. Here base value is e. That means y equal to e power minus 5t plus c. So this implies y equal to e power minus 5t into e power c. Now what is my boundary condition? Y value is 2 when t is 0. Apply this boundary condition. Y value 2 when t is 0. Therefore e power c becomes 2. Again replace this e power c by this constant 2. Then this becomes y equal to 2 times e power minus 5t. Now replace t by 3. That means y value at t equal to 3 is 2 times e power minus 15. So therefore the answer for this question is option number C. Y of 3 is 2 times e power minus 15. Note it. Now we discuss question number 5. So it is a differential equation di by dt minus 0.2 I equal to 0. Di by dt minus 0.2 I equal to 0 is applicable over minus 10 less than t less than 10. If I of 4 equal to 10, then we need to find I of minus 5. We need to find I of minus 5. It's a blank question. So we need to find particular solution. After that, t is replaced by minus 5. Here the boundary condition is I of 4 equal to 10. What does it mean? When t equal to 4, I value is 10. What is I? Here I is a dependent variable, t is independent variable. So therefore we get the result for I in terms of t. This equation is equivalent to di by dt equal to 0.2 I. Cross multiply this 1 by I into di equal to 0.2 dt. Now t variables are one side, I variables are one side. Apply integration on both sides. Integral 1 by I di equal to integral 0.2 dt plus c. So this implies log I equal to 0.2 t plus c. This implies I equal to base value is e, so it becomes e power 0.2 t plus c. This implies I equal to e power 0.2 t into e power c. Now let us apply this boundary condition. T value is 4 when I equal to 10. So I value is 10 when t equal to 4. So e power point it into e power c. This implies e power c equal to 10 into e power minus 0.8. Therefore, in place of this e power c, we can write 10 into e power minus 8. Therefore, I equal to this e power 0.2 t into 10 times e power minus 0.8. So I equal to 10 times e power 0.2 t minus 0.8. But we need to find I of minus 5. So replace t by 5 minus 5, you get 10 times e power minus 1.8. And this result is approximately 1.65. This is our final value. I of minus 5 is 1.65. Just it is based on method 1 only. Just like previous questions 1, 2, 3, 4. Consider dy by dx equal to xy. If y equal to 2 at x equal to 0, then y value at x equal to 2. Boundary condition is given, equation is given, we need to find y value at x equal to 2. Options are given in terms of powers of e. Let us solve this. This is dy by y equal to x dx. Variables are separated. So this implies integral 1 by y dy equal to integral x dx plus constant c. Integral 1 by y dy means log y equal to x square by 2 plus c. Base value is e. This implies y equal to e power x square by 2 plus c. This implies y value equal to e power x square by 2 into e power c. Now apply this boundary condition. What it is, y value is 2 when x is 0. So therefore 2 equal to e power c. So therefore this e power c is replaced by 2. So the particular solution is y equal to 2 times e power x square by 2. But we need y value when x equal to 2. So y of 2 equal to 2 times e square. This is my final answer. The answer is 2 times e square. So therefore the answer for this question is option number B. B is right answer. Now let us move to question number 7. What it is? The solution of dy by dx equal to y square with initial value y of 0 equal to 1 is bounded in the interval is. See, bounded means it's a finite value. Bounded means it's a finite value. In options, intervals of x values are given: minus infinity to plus infinity, minus infinity to 1, x less than 1, greater than 1, minus 2 to 2. Bounded means it's a finite value. Let us see for what values of x this differential equation has a finite value, finite solution. First, let us try to find its general solution. Apply this boundary condition, you get particular solution. Based on that, you can easily get for what values of x the function takes bounded solution. Now this is 1 by y square into dy equal to dx. Y variables are one side, x variables are one side. So integrate on both sides. Integral 1 by y square dy equal to integral dx plus c. So integral 1 by y square is minus 1 by y. This can be done like this: integral y power minus 2, integral y power minus 2 dy. So this is y power minus 2 plus 1 by minus 2 plus 1. This is nothing but minus 1 by y. So in place of integral y power 1 by y square, we can write minus 1 by y equal to x plus c. This implies y equal to minus 1 by x plus c. Now the boundary condition is this. That means x value is 0. When x is 0, y value is 1. So replace y by 1, x value is 0. We get 1 equal to minus 1 by c. This implies c equal to minus 1. Therefore, replace c by minus 1 here. We get y equal to minus 1 by x minus 1. Therefore, y equal to 1 by 1 minus x. Now, this is my particular solution. You can easily get this now. In the denominator, we have 1 minus x. 1 minus x, see, when you have a rational expression, if denominator gets 0, the solution becomes unbounded. Unbounded means, for example, infinite region. 1 by 0 means infinity. Therefore, this solution becomes bounded only if x not equal to 1, because when x is 1, 1 by 0, it becomes infinity, unbounded. So to get the bounded region, x should not be equal to 1. It can be negative or positive. When x is not equal to 1, denominator is not equal to 0. That is enough for us. X not equal to 1 means it can be less than 1, it can be greater than 1. Therefore, to get the bounded solution, denominator should not be 0. So therefore, 1 minus 6 will be 0 only when x is 1. Therefore, to get the bounded solution, my choice is x should not be 1. It can be less than 1, it can be greater than 1. So therefore, option C is right. Note this. Now let us discuss question number 8. The solution of dy by dx plus 2y equal to 0 for the boundary condition y equal to 5 at x equal to 1 is the solution of dy by dx plus 2y equal to 0 for the boundary condition y equal to 5 at x equal to 1 is options are given. Now they ask a particular solution. So if the options are given as particular solutions, so don't do entire work, just go through verification of options. As I mentioned earlier, if only one option satisfies given boundary condition, you can opt it. That could be right answer. Let us verify options. In first option, y value is e power minus 2x. In option A, we have e power minus 2x, but x should be 1. So when you replace x by minus 1, e power minus 2, that is not equal to 5. So option A is wrong. Let us go back to option B. That is 2 times e power minus 2x, but replace x by 1. 2 times e power minus 2, that is not equal to 5. You can easily verify. Here e value is 2.71. This is Euler's constant. So therefore, first option does not give 5 when you replace x by 1. The same case with second option. So eliminate this. What is option C? That is 10.95 into e power minus 2x, but replace x by 1, you get e power minus 2. Even that is also not equal to 5. Therefore, eliminate C also. So first 3 options do not satisfy the given boundary condition y equal to 5 at x equal to 1. So we can eliminate option A, B and C. So ultimately D is right answer. So only one option satisfies given boundary condition. Just when you go through order of verification of options, option A fails, option B fails, C fails. Therefore ultimately you can eliminate A, B and C, then D is right answer. This is one way. So we are lucky in this case. But even in the different way, you can solve it by going through options. In the first option, it is 1 times e power minus 2x. Second, 2 times e power minus 2x. Third one is 10.95 into e power minus 2x. Fourth one is 36.95 into e power minus 2x. When you observe all options, one function is common. What it is? E power minus 2x. Only there is a variation in terms of constants. Therefore, just by looking at the options, the one can easily guess that the general solution becomes y equal to c into e power minus 2x. Now let us try to find c value using this boundary condition. Y value is 5 when x is 1. So 5 equal to 1 into e power minus 2x, c into e power minus 2x. So this is c into, replace x by 1. So 5 into e square. This we get 36.95. Therefore, the answer D is right answer. Note this. So you can write like this, only option D satisfies given boundary condition, so D is right answer. You can write like this, only option D satisfies given boundary condition, right? Next we move to question number 9. So it is, biotransformation of an organic compound having concentration X can be modeled using an equation dx by dt plus kx square equal to 0. Dx by dt plus kx square equal to 0, where k is the reaction rate constant. One boundary condition is given. What it is? X equal to a when t equal to 0. Then its solution is given. Here x is dependent variable, t is independent variable. Even boundary condition is given. In the options we have particular solutions. Dependent variable is x, independent variable is t. So when you try to solve its general solution, you will get the value of x in terms of t. So when you apply boundary condition, you will get the right answer. Before doing like that, you can go for verification of options. Let us try to verify options. What is the first option? X equal to a into e power minus kt. A into e power minus kt. So when you replace t by 0, you will get x value is a. So this is option A. So first option satisfies given boundary condition. If it satisfies given boundary condition, don't confirm and don't eliminate, hold it. Now let us verify option B. It is 1 by x equal to 1 by a plus kt. The same situation, when you replace t by 0, x is a. So it also satisfies given boundary condition. Don't confirm, don't eliminate, hold it. Option C. So option C is x equal to a times 1 minus e power minus kt. Now when you replace t by 0, here also you are getting x equal to a. Don't confirm, don't eliminate, hold it. Now D. D is x equal to a plus kt. The same case. When you replace t by 0, you will get x equal to a. So we are so unfortunate in this case. All options satisfy given boundary condition. So we don't have any alternative. We need to solve this question. But when you are doing integration, just with 50% or 40% of evaluation, just you can cross verify these calculations, you can get easily. Let us do that. in that way. Now let us see this. This equation is dx by dt equal to minus k x square. So this implies minus 1 by x square into dx equal to k dt. Now variables are separated. Apply integration on both sides. Integral minus 1 by x square dx equal to k into integral dt plus c. So this implies integral minus 1 by x square, 1 by x equal to kt plus c. So the result is just like this, 1 by x equal to kt plus c. Now you can easily verify, you can easily get that answer is B, because 1 by x equal to kt plus c. In option B, we have c value as 1 by a. It is in the form 1 by x equal to kt plus some constant. 1 by x equal to kt plus some constant. That constant is given as a, 1 by a. Therefore, option B is right answer. You need not verify, you need not go for calculation of C also. So the answer for this question is option number B. If you want to cross check it, find the C value, you get 1 by a. Apply boundary condition, x value a, t value is 0, then C becomes 1 by a. That is happening only in option B only, because in the first option e power minus kt is there. There is no exponential function. In option C also exponential function is there, but in the solution we were not getting any exponential function. So with that you can eliminate option A, C. When you apply boundary condition, you are getting C equal to 1 by a. Replace x by a, t by 0, C becomes 1 by a. Therefore option B is right answer. Next we move to question number 10. So what it is, the general solution of dy by dx equal to, the general solution of dy by dx equal to 1 plus cos 2y divided by 1 minus 1 plus cos 2y divided by 1 minus cos 2x is dy by dx equal to 1 plus cos 2y divided by 1 minus cos 2x is. When you go through options, option A and C look like same. In option A, we have minus between tan y and cot x. In option C, we have plus between them. Option B and D look like same. Between tan x and cot y, there is minus symbol and there is plus symbol. So be cautious about integration or derivatives. Integrations, they make very powerful sense. So let us try to solve this. You can handle this by separation of variables. Now before going further, let us simplify what is 1 plus cos 2y, 1 minus cos 2x. We have a formula for cos of a plus b. The formula for cos of a plus b is cos a into cos b minus sin a into sin b. But I want 2 times of single variable. So suppose if I take b equal to a, then this equation becomes cos 2y equal to cos a into cos a, because b is replaced by a. Cos beta equal to cos square a minus sin square a. But I want result in terms of 1 plus cos 2y in terms of cos a. Therefore here I can write this is sin square a as 1 minus cos square a. Then this becomes 2 cos square a minus 1. Therefore, 1 plus cos 2a equal to 2 cos square a. Similarly, when cos square a is replaced by 1 minus sin square a, then my equation becomes cos 2a equal to, in place of cos square a, write 1 minus sin square a. So 1 minus sin square a minus sin square a. Therefore, we get it as 1 minus cos 2a equal to 2 sin square a. Therefore, in place of 1 plus cos 2y, we can write 2 cos square y. So this equation is dy by dx equal to, in place of 1 plus cos 2y, we can write 2 cos square y. In place of 1 minus cos 2x, you can write 2 sin square x. 2 will get cancelled. So dy by cos square y equal to dx by sin square x. Now variables are separated. Apply integration on both sides. Integral 1 by c cos square y means secant square y. So integral secant square y is integral cosecant square x dx plus c. Integral secant square y is tan y. Integral cosecant square x, derivative of cot x is minus cosecant square x. So if you want, you can write two minus symbols, or integral cosecant square x is minus cot x plus c. Because cot x derivative is minus cosecant square x. So minus cot x derivative is plus cosecant square x. Therefore, this implies the result is tan y plus cot x equal to c. So this is my final general solution. What it is, tan y plus cot x equal to c. So option number C is right answer. Tan y plus cot x equal to c. Only thing is, you need to know 1 plus cos 2y and 1 minus cos 2x. So for both the issues, I must know cos 2a formula. Cos 2y is required, cos 2x is required. So in general, I want cos 2a. So the general formula for cos of a plus b is this. Cos a cos b minus sin a sin b. If b is a, then cos 2a becomes this. Replace sin square a by 1 minus cos square a. You get the expression for 1 plus cos 2a in terms of cos square a. If you want expression in terms of sin square a, replace this cos square a by 1 minus sin square a by keeping sin square a as it is. Then the result is 1 minus cos 2a equal to 2 sin square a. Therefore, when you simplify this, finally variables are being separated, and then get the general solution by method 1. You get tan y plus cot x equal to c. The same formula even we can use in transform theory techniques, particularly Laplace transform techniques. Note this. Is this clear? Now we move to question number 11. What it is? The general solution of dy by dx equal to cos of x plus y. The general solution of dy by dx equal to cos of x plus y is, options are given. Now you can see it is actually in the form dy by dx equal to, it is in the form f of ax plus by plus c. It is in the form f of ax plus by plus c. A value 1, b value 1, c value 0. In that case, this z is nothing but x plus y. What in that case, see, I am going to solve this by substitution method, because it is in the form dy by dx equal to f of ax plus by plus c. In this case, a becomes 1, b becomes 1, z is x plus y. So my f of z is cos z. F of z is cos z. Now you can handle this by using substitution method. So I think session is going to be finished within a short few minutes. So let us continue this question in the next session. Hope you enjoyed this session. So let us continue this question in the next session. Thank you so much.